Hi there, this is Andrea Hendricks. We're going to now take a look at trigonometric functions from a different perspective. We're going to use the unit circle. So some objectives that we need to cover are to use the unit circle to define the 6 trig functions, evaluate trig functions using the unit circle. We're going to use the domain and period to evaluate sine and cosine functions, and then other properties of even and odd to evaluate trig functions. So let's go ahead and take a look at that first objective, to use a unit circle to define the 6 trig functions. First off, you need to know what a unit circle is. A unit circle is a circle whose center is at the origin and whose radius is 1. If you recall from college algebra, the standard form of the equation of a circle is x minus h squared plus y minus k squared equals r squared, where the center is the center is hk and r is the radius. So we can put the origin in for hk and 1 in for the radius to get our circle would be represented by x minus 0 squared plus y minus 0 squared equals 1 squared, which simplifies to be x squared plus y squared is equal to 1. So the equation of our circle is x squared plus y squared equals 1. Well, what's really interesting is if we put on here some things that we talked about before with the right triangle. Let me superimpose this right triangle on top of our unit circle. And so some things that we know about that is that the radius is 1, okay, and remember to go from a point from the origin to a point on the circle, we would have to go over x units and up y units. So this point here can be represented by the ordered pair x, y. And x is our horizontal distance and y is our vertical distance. Well, recall also that we gave this angle a name, let's say theta. And so whenever we are looking at this from a right triangle perspective, we can talk about the trig functions that occur. And so let's talk about what would the sine of theta be. So in this case, sine of theta is opposite over hypotenuse, which would be y over 1, or just y. And what about cosine of theta? Right, that is adjacent over hypotenuse, or x over 1, which is x. So this is really, really interesting. It tells us that if theta is an angle, and we can think of now theta not really as an angle in a right triangle, but we can think of theta as a central angle, right, because it has an initial side on the x-axis, and a terminal side is here, and that is defined to be the amount of rotation. Right, so theta is our central angle, or in fact the book uses t, which is what notation I'll be going to in just a minute. But this is really interesting then. If we have any angle theta and it intersects the unit circle, at that point xy on the unit circle actually has the coordinates which give us cosine theta, sine theta. That's pretty cool, huh? So now we can use that and extend our definition. Every point T on the circle corresponds to an ordered pair x, y. Well, the point T corresponds to central angle, right? So if I have this, I should have used my pneumatic that I just had over there. Okay. So if we have a point T on the circle, in fact, what we're really doing is, if you can think about this as being 0, and you can wrap the real number line around the unit circle, because in the counterclockwise we're going in a positive direction. If we go clockwise, we're going in the negative direction. So any real number t corresponds to a point xy, where t is really nothing more than the angle, right? Because t is our arc length, okay? So we have really a central angle T. So the point T corresponds to a central angle. The number T is any real number. Then we know that this happens, that the cosine of T is really equal to that x value of that point, right, if this is an x and y. So cosine of T is x, sine of T is y, and therefore we can define the other trig functions in terms of that. So tan T is y over x, cosecant is the reciprocal of sine, so that'd be 1 over y, secant is the reciprocal of cosine, 1 over x, and cotangent would be the reciprocal of tangent, which is x over y. And notice we have the restrictions that we can't divide by 0, and we'll talk more about that in later sections when we get into the domain of those functions. But this is how we use the unit circle to define the trig function. So it really comes from that right triangle that we started talking about. We're not limited now to have an acute angle because T can go anywhere around the circle. So in the next video I'll show you how you can use the unit circle then to evaluate the trig functions.